Welcome to our talk, the Moby Project, Past, Present, and Future. And we'll be taking you on a journey through the history of the Moby Project. There's going to be a trip down memory lane, how it all began to be, history behind it, the direction we are going, future work as well. And we're trying to do a Q&A at the end as well. If you don't want to do it during the Q&A, we'll stick around for any questions you have. So feel free to stay around. But first, let's do a short introduction of us. So I'm Sebastiaan. I work at Docker as a software engineer. I've been at the company since 2015. And before that, I started using Docker in 2013 already. I found it very fascinating, wanted to learn more about it, and got involved in the project. And in 2014, I became a maintainer, got involved in the project, ultimately got at Docker, and I'm still there. And currently, I'm engineering lead of the runtime team at Docker, trying to get the open source going and the runtime running.
Yeah, and I'm Bjorn. I am also an engineer at Docker. I've recently started there, but for a little longer. I've also been a maintainer of the Moby project. I'm a relative newcomer to the project. I've used Docker for 7, 8, 9 years, somewhere in there now, but have not been involved in more than advanced users' knowledge of the internals, or actually working on the project up until recently. So my perspective is a little different, but we work on the same team, and want to share more or less what we've been working on and how we got to where we are today.
Okay, let's get started. So 2023, it's 10 years ago since Docker started. There's a lot of history there, and let's have a look at what happened in those 10 years. A short trip down memory lane, I could probably talk for hours. We tried to condense it, and now I'm afraid I have too little, so we'll see. Let's get started. Containers, they've been around for a long time, and a long time before Docker. There's many implementations of containers in multiple variants. We listed a few. LXC is most notably related to Docker. We'll get to that later. But people are using containers as lightweight VMs, a lightweight way to isolate processes. They were hard to use, and they were really a niche case. People were using it. It was not widely used because it was just too complicated. And it also didn't solve some of the problems that Docker later started to solve. Is you got pet VMs or pet containers. It was hard to keep in sync. There was no distribution of images or anything. It was a lot of hand-on holding. So what changed? How are we? Go back, go forward. So yeah, as I mentioned, sorry for that, it keeps going back. Are we going? Doesn't want to move forward.
I can advance for you.
Does it stick? Now it goes. So what changed? So 10 years ago, there was a small platform as a service company, .cloud, and they were offering services. And behind the scenes, they were using some technology, containers. And they mostly use Python, a lot of scripting, making things work. And the company was going, but people started asking questions as to, hey, what's the technology you're using? This sounds interesting because you're offering a service. Can I do this myself? And from one came another, and they decided to open source what they were using internally. During PyCon 2013, Solomon Hykes presented Linux containers, the future of Linux containers. It was a lightning talk. It was 5 minutes, but I think it was causing quite a ripple in the industry, because within those 5 minutes, he showed a Docker run for the first time. And that Docker run did a lot of the work that you needed to do with LXC, but just in a single command. So they open sourced it, and it was pretty early on, and Docker was still a wrapper around LXC. Basically, LXC did all the heavy lifting, Docker did the things on top. But they did add some interesting things to it. It provided an easy-to-use UX, but also an image format. And especially the image format made a big difference because now you no longer had to create your own file system for a container. You could just use an image, and you could start working it. But it was pretty early on. There was no build, so if you a Docker build didn't exist, so if you wanted to create your own image, you either had to run a container, commit the results, do the next step, and commit the results again. It was still early stages. But it did cause a big impact on the market, because for the first time, Linux containers became a reality. It got in the hands of the developers. Docker did a lot of things there. And it seemed small, and I don't think the people working on it ever expected it to be taking off that big. But how did it get there? I think because it was opinionated. It limited the use of the containers in a way that was opinionated, but because of that, it was able to move forward. A lot of projects are often grinding to a halt if there's too many people on board and trying to get opinions and features. And Docker always remained opinionated, a limited set of functionality, but what most people were using. One of those things was to make containers more of an isolated process, not so much a VM or mimicking a VM, but more of a focused task isolated from other things. And that pushed the direction in many cases. It also started to provide more tools, like you can now build your own images using Docker files, which was a pretty easy way to create your images, not too complicated like other solutions. And it provided an API, and that turned out to be pretty important because having an API makes developers do cool things, which was both a blessing and a curse, which we get on later. But the overall image format and everything pushed the market forward. The project was moving fast. So as I said, initially it was based on LXC. It turned out that LXC was working, but not always the same scope as the project was having. So at some point, we decided to rewrite the runtime, have a native runtime built into the Docker engine, which was libcontainer. It was basically a framework to create containers. Initially, it was in the engine, but later on, it proved to be a much more important role. More things were added, volumes were added, networking was added, and the CLI became a separate binary. Initially, Docker was a single binary. It was a static binary created in Go, which was a new language, and later on, the CLI became separate. And to some extent, we already started to componentizing things. What happened next? So the project took off, and because containers were focused on single tasks, people needed more than one containers in most stacks. And how do you run multiple containers other than spinning up a few and trying to keep them running? And you saw the first showing of orchestration. Initially, it was Fig, which later became Compose. It allowed you to define a YAML file. These are the containers I need. This is how they connect to each other. And with a single command, you could run it. Fig got acquired by Docker and became Docker Compose. But there were also other projects coming. Docker started Swarm, first a V1, which allows you to run your containers in a cluster of machines. Kubernetes came to be. Kubernetes decided to use Docker as a runtime because it was the de facto standard for running containers. And other tools became or came on the market and started to develop on top of Docker. Initially, great, awesome, everyone is using Docker. And then the problems became because there were so many people using Docker and trying for their own purpose that there were many conflicts at some point in the whole decision making. Features that people were requesting but were clearly out of scope for the project. And in some cases, we had features in Docker because we had opinionated views on things that others didn't need. Kubernetes didn't need the networking stack of Docker. They didn't need other things that we were providing, but they were still using the runtime. And things were challenging at times. I can tell long stories about this. So yeah, the engine as a monolith became more and more of an issue. People were asking to add features, remove them. There were also people that were about the whole standardization of things, because Docker was the de facto standard, but there was no formal specification of images or containers or how the runtime should behave. The implementation was the specification, and that is not always ideal. Some people on the market tried to push their own standards, so AppC became a thing, Rocket became a new runtime. And well, that wasn't fun at the time. I think it pushed the things forward. And at some point, Docker decided to start with splitting out the actual runtime. So the OCI runtime, libcontainer became runC. At the same time, we started the OCI, a standard organization where all people could, or companies could work together, and to which we donated the specifications we were using for both distributing images as well the runtime specification and images. That became the foundation of other runtimes coming to existence, and now other people could implement their runtimes and images and registries, not just Docker. And for Kubernetes, we started in a whole new path because we had the runtime, but we learned a lot of things over the years. We made bad choices. And we started to write the runtime from scratch. With a couple of partner companies, we worked on Containerd, which was a complete rewrite of the runtime parts of Docker, but this time pluggable in smaller components and to be used as a runtime for higher level systems, which could be Kubernetes or anything else. And now we go further. Beyond that, we also started to split the projects from the product we had. So the Moby project, how did it come to be? So we had the Docker engine, but people wanted to not only use Containerd, but also other parts of what we had. So the decision was made, let's split this project even further. Let's make it smaller components. So we got BuildKit for building. We got SwarmKit for orchestration. We got the Docker engine. The CLI became part of the Docker product. So it's a separate project, but the runtime itself all became the Moby project. And that could be used for others to build on top of, use, participate in, but also it made it easier to accept changes that may not directly benefit Docker as a product, but could be used by others and vice versa. And then the Docker itself also changed. So a few years back, as you may know, Docker had both the enterprise products and more developer-oriented products. And at some point, it became clear Docker was moving in two directions. And we were always founded as part of a developer tooling org. And the enterprise side went to a different company. It went to Mirantis, and Docker was back to its roots. We were working on developer tools. We had Docker Desktop as a developer tool. We were working on other great tools, not so much the orchestrating things and not so much the enterprise side of things, really the greatest developers tools. For the Moby project, it had some consequences. At the time, we were a much smaller company, less contributing to the open source at that point because we were focusing on Docker Desktop. So for some time, you saw lower activity, but it's back. And the last 18 to 24 months, we got a lot of work. We got more maintainers. We got people from Mirantis working, people from Microsoft working on the project. And things are moving forward. And that's where I hand it over to Bjorn, because he's going to be talking about the present and the future.
Yeah, so like Sebastiaan mentioned, the state of things has been slowed down significantly, in the relatively recent past. But we've also been seeing a lot more activity in the project, and I think that's visible in various forums. It's not maybe communicated the best, so hopefully I can summarize a little bit of essentially what has been happening. But first, before we get into that, one thing I want to mention is, still, despite the fact that there is a much more diverse landscape of container runtimes, of ways that people run containers, of tools that are building on top of containers, the Docker engine is still very widely used. And so, that's a large part of that. That focus initially on Docker Desktop was to focus on the thing that Docker Inc. was selling that was making money. But it was realized, pretty early on there that we can't stop investing altogether in this core technology, both because we consume it internally and because there are a lot of users. So, one of the graphs that I end up looking a lot at here is the scale and the usage just of the packages we provide through download.docker.com. So these are the official Docker CE binaries that are built by the Docker team. This graph here represents a pair of unique IP address and Linux distribution showing the downloads from our Linux package repositories. This is kind of both like everything from your curl, get.docker.com to bash. It's tools like KubeSpray, older versions that still use the Docker shim, that still rely on Docker as a runtime. And there's even some other tools that I've mentioned that build on top of Docker, on top of the Docker engine that still download here. So also represented in this data is things like Rancher Kubernetes Engine 1, as well as the new, I think it got renamed, it was called Mrisk, but now it's Kamal, I believe, tool that was released by, and I guess they're Basecamp now again. So one of the things that keeps me up at night is this. This is not an uncommon pattern. Right here we have a piece of software that is building on top of the Docker engine, and it turns out, the way that it installs it is to curl bash. And so, even keeping that working is pretty critical. If this shell script breaks, or if it was ever compromised, a lot of people would notice very quickly, and perhaps violently. So there's definitely a I guess it's the stressful side. It's great to have a lot of users, but people come to depend on you in unexpected ways, and that's important to understand because something you may think is innocuous, may completely break what somebody else is doing. Talking about activity again on the open source project, it has significantly picked up in the last 18 to 24 months. So like Sebastiaan mentioned, we have a fair number of participants, not just Dockering. I think it's one of the things that confuses people is, what happened to the open source code known as Docker, but maybe it also helps explain a little bit that there are more participants, and not just participants, but people who are stakeholders in the project than just Docker Inc. So most recently and most visibly, that's been Microsoft and Mirantis. I actually previously worked at Mirantis before I came over to Docker, and that is actually where I started contributing to this project. But there's plenty of others as well. I mean, another good example of this recently has been NVIDIA contributing container device interface support. We'll get to that later, as well as the fact that there are, as always, independent, unaffiliated contributors who are not contributing on part of any as any sponsor of their open source work. Often is just somebody scratching their own itch or trying to solve their own problem. However, I think it's notably when people see the project as a whole moving faster, they are more likely to contribute because, oh yeah, it's more likely that my contribution will be reviewed, more likely it will be accepted. And likewise, talking about having more people involved, more people at the table, we've also managed to significantly reduce the bust factor. I think it's still a lot lower than we would like. If Sebastiaan was hit by a bus tomorrow, we would be in a very bad way. But there's definitely a lot of the, even a lot of the knowledge. We were talking about today, a lot of that history, a lot of the context of why are things a certain way that is very precious and hard to replace. We are trying to share that as widely as we can. And just here we have a screenshot of the GitHub activity on the engine GitHub repo recently. This is just a snapshot of the last month. I would say that maybe this data is a little misleading. We have a lot more closed issues than we otherwise normally would have because Sebastiaan's been trying to clean up a lot of stale issues, but it does give you an idea of the relative velocity of the project is very high these days and is higher than a lot of peer or similar projects. We've had a number of recent releases too. So the most recent release of the Docker engine was in 2020, prior to this last year. There has been a lot of code, a lot of improvements that never found a release vehicle for years. There have been sometimes dubiously wise backports to that existing 2010 release branch because there was simply not a better vehicle to release them through. And so one of the big one of the painful but necessary parts of making the project more active was kind of getting through that, getting the release train going again, I guess, essentially. So this year we've had 2 major releases so far. I actually have a space here on the slide. You know, we were hoping to have a 25 release right before DockerCon, but going back to that, how many people depend on the Docker engine and may in fact install it, trusting us to be competent in, you know, what we are shipping to them. A lot of circumspection is sometimes needed, you know, in performing these releases, and that's what made it so hard for such a long time with limited manpower. And so, you know, we don't have that yet. We probably will have some betas of the 25 major release, and we'll get to a little bit about, you know, what is planned to be in there in the next week or two. So, you know, shipping is hard. There's a lot of technical debt. There's a lot of people depending on you, and, you know, or if you haven't released for several years, but you've had feature development the whole time, even looking at what you have and making sure that it's coherent, everything that was supposed to get in got in, that you have release notes for it, you can explain it to people, it's documented, that's a significant challenge. We're definitely getting better about that. I mean, I do think that we will be ending up with 3 releases of the engine this year, but it's still a significant challenge. We are getting better every time. So like talking about those major features, you know, this is, if you've paid attention to the release notes on docs.docker.com, you know, or the GitHub repo, Moby, you might have seen these, but if not, just a quick summary of some of the things that, you know, have been shipping or will be shipping that are, you know, really new and interesting. I think the big one, you know, that has been worked on for a long time, Sebastiaan mentioned BuildKit, which is a rewrite of the builder that is a, you know, a separate reusable project that can be used in many environments by things that are not the Docker engine, but we also do have a version of it that is embedded in the Docker engine. Part of BuildKit's original mandate and, you know, plan was to have it replace the classic legacy builder in the Docker engine and provide a much richer and more flexible build platform that still is as simple as Docker build. So BuildKit is on by default now. A lot of people have been setting Docker BuildKit 1. We have an environment variable that allowed you to enable this. It was, I guess, maybe not like an experimental feature, but it was something of a beta feature for a very long time. Another thing that's interesting, and I think that surprises people, is that there are still new features in Docker Swarm. We talked a little bit about how Docker's answer to Kubernetes and to orchestration eventually became Swarm, and the modern incarnation of Swarm that we know today is called SwarmKit. It's never going to eat the world, you know, at this point. I would say that Kubernetes is very much the de facto platform for orchestration, and you probably shouldn't choose something other than Kubernetes, you know, unless you have a very good reason, if you need the level of flexibility and complexity it adds. But there is a, you know, small but still very vocal group of users who enjoy using Swarm and who want Swarm to be, you know, do more things or even be compatible with a lot of the add-ons and extensions that exist for Kubernetes. So that's, you know, essentially what this is. The container storage interface is the interface that Kubernetes uses to interface with different providers of distributed persistent storage and make them available in a container. And there is experimental support for it in Swarm now. And then finally, kind of the other interesting thing here is for a long time, the engine has supported alternate runtimes, other ways to run a container, but they have had to be essentially drop-in compatible with runc, the reference implementation. So there's also now better support for making use of the engine with gvisor, with kata containers, or, you know, it's not actually on the slide, but with WebAssembly. And, you know, it is one of those things which is, you know, boring maybe, but opens up a lot of possibilities, especially for people inventing new ways to run a container or run something that looks kind of like a container, like WebAssembly. For the 24 release, which happened earlier this year, you know, I've got one thing on the slide here, which is containerd. And that's a little confusing because we talked about how containerd was a replacement for the runtime layer of the engine, but the engine has used it almost since the first version. We'll get to that in a minute. You know, specifically what we're actually talking about here is using containerd for storage and not just for execution. And then, you know, those of you who are eagle-eyed or like to live on the bleeding edge might have noticed a checkbox at one point or another in Docker Desktop, you know, to use containerd. We'll get into a little bit of what is that actually doing. So then, you know, finally for the 25 major release that we're hoping to do in the next couple weeks here, originally before DockerCon, there's still, you know, yet more interesting things. There's everything from, I mentioned that contribution by NVIDIA, support for the container device interface, which is something of a developing or emerging standard for how to take a device, a hardware device, and make it available to a container. And that's not just as simple as passing through the kernel interface. It can be everything from making the shared objects that are needed to you know, a library used to interact with that device. It can be modifying the configuration and definition of a container to better make use of that hardware. And this is a pluggable interface that other container runtimes have adopted, and Moby has gained support for as well. Another really interesting thing that's been long in the making, I think it's interesting for me as somebody who has to work on this, maybe not so much for everyone, but is support for open telemetry. So we have a screenshot of Jaeger here. We actually have open telemetry just recently in the last couple of weeks integrated into the engine. And so there was much better insight into this particular thing that the engine is doing is taking a long time. Is it my code, potentially, if it's running in a container? Is it a bug in Docker-D? Or for us working on it to actually have better visibility into what our code is doing and to better instrument it. And then finally, there's also lots of little things that I think can often have a disproportionate impact. The one that I'm most excited in 25 being graceful health checks. A long pain point with the exec-based health checks, like in a Docker file, is that either I define the start interval to be long so that the thing in the container has time to boot up, but then that interval is set for the entire lifecycle of the container after the container has reached a steady state. Or I define a short interval, and I can kill a container that was just a little bit slow to start, or maybe the rest of the system is under heavier load, and I'm killing perfectly good containers. I killed a container, I try to start a new one to replace it, but because the system is still under heavy load, I don't give it enough time to boot up, and I kill that again. So even just making long-standing features of the engine work a little better or address some of the complaints people have, I think is still quite exciting. So going back to the container-D thing, it's actually like all that our team talks about for the most part. I mean, probably 80% of it. It's maybe a little hard to understand at first because of we use container-D, but we don't use container-D, so I want to go a little bit more into that. And it's a checkbox in Docker Desktop, but it's not immediately obvious by checking that box what you're doing. So first off, this is a pretty big invasive change. Like we're replacing the thing that basically not only keeps track, when we say storage, it's not just where the container image is stored, it's actually also the thing that even keeps track of what your containers are. All the persistent state that you might have in a container that you Docker create, Docker start, Docker stop, that is also defined by the storage interface. So the analogy that Sebastiaan has drawn is we're trying to chart a graceful transition here to a completely new architecture, something like the transition that Apple made from Mac OS to OS X, or from PowerPC to Intel, Intel to ARM. Trying to change a foundational component but make it minimally disruptive. Not everything's going to be one-to-one, but hopefully once we get it right, it will be better for everyone. So actually enabling this container feature, you can use it today. So it's experimental, it's not enabled by default. So in the 24 release, there is a JSON snippet you can add to your daemon JSON. There's a docs page. If you search for this in our docs, you'll find container-D pretty quickly. But there is a undocumented, except on docs.docker.com, key that you can set in the daemon JSON to enable this feature. Or we have a handy checkbox that turns it on for you in Docker Desktop. That actually does more than just turning on container-D. It uses a different snapshotter than the default, but we'll get into that in just a second here. So here is kind of just a high level, hopefully this isn't too specific, a high level diagram of how Docker and Docker-D and container-D relate to each other today. So the key takeaway here is that the storage code lives entirely in Docker-D. We interface with the registry in Docker-D. And then as we store things, we actually basically store two kinds of data. So we store content. Content is like the contents of a file. We store that in something called a graph driver. And basically what happens is we extract layers onto disk. But then those layers are defined as tar files. We actually take the metadata from those tar files and we put them somewhere else so we can use them later. This is essentially done so that when we go to push content, we can take the contents that were on disk, we can take that original metadata we saved, we can put them back together, and we can reconstitute that and then push layers. There's some limitations to this approach, though. Some of them are intrinsic, some of them are more architectural and are easier, better addressed by standardizing on what container-D has come up with than trying to tweak this architecture further. The big one is that we store uncompressed content and uncompressed tar headers. So gzip is not deterministic. When we go to push content to a container registry, the compression of those layers happens on the fly. This is the reason when you do a Docker build, you can't know the digest of the image as it's going to show up in the registry until you first Docker push. And then we get a digest back. The registry reports what we push to it. We don't store those compressed bytes. So every time you Docker push, you actually end up with a new digest because the content is changing from the perspective of the registry, which is just storing these compressed bits of content. And so here in this diagram, we have a section that is not used at all. It is this, this containerd storage interface we don't use. All of our storage is defined purely in terms of Dockerd, and we don't store compressed content. We store content and metadata. In contrast, this is what it looks like with the containerd integration that we are working on, where we use containerd to power storage. So our storage backend remains the same. Inside Docker, we actually have an interface that we can switch in the same code base between these two implementations. Our storage is then a facade over containerd storage, and containerd provides a large amount of critical functionality. So we both use containerd now to talk to the registry, and then that content from the registry is moved into containerd's storage service. There, containerd's critical architectural difference is that it stores distributable content and runnable content separately. So distributable content would be what can I actually push to the registry? It's the compressed layers, it is the actual raw bytes that represent this container image. Runnable content is after I've extracted that onto disk. So in containerd, this is an operation called unpack. Essentially, it is storing everything twice. We store the copy that is stored in the registry, and we store the copy that will be used by the runtime to actually run your container. So it has a number of advantages. It lets us do a number of interesting things. It does cost more disk space, but the theory here, and this was the theory behind containerd, is that disk space is increasingly cheap, and the flexibility of storing this and being able to push the same content somewhere and have it reproduce with the same digest every time, it outweighs the downsides. So why do this, right? Other than there's technical debt, we don't feel super great about fixing some of the issues in the graph drivers. Why also start over with containerd? So there's a couple interesting things that you can do with it. The first one that I think is like the headline feature, it doesn't quite fully work today, but we're most of the way there in Dockerd, is to store and work with multi-platform images. So today, when I pull a multi-platform image in Docker, we support multiple platforms. However, only one platform can be stored locally. Containerd's more flexible model of storing content and unpacked content, distributable content, runnable content, more easily allows us to store multiple platforms and to make our API multi-platform to allow us to work with multi-platform images, natively, and less as just, a multi-platform image today in Dockerd is basically just, here's a bunch of images, and we dereference to the concrete image, the concrete platform, and then that's what we work with. So it allows us to natively work at that higher level of abstraction that is a multi-platform image. It also means that we can just start to do things that are seemingly trivial, move content around, like Scopio or Regcuttle, where we can just take the bytes and move them from A to B. It turns out that the existing implementation doesn't have a way to store those bytes necessarily, not in all cases. This actually allows us to do that. It also means flexible and pluggable storage backend. So I mentioned like the checkbox in Docker Desktop actually also currently enables the StarGZ snapshotter, which is a storage backend for containerd that allows for lazy pulling of images. So I don't have to have all the content to start executing. I can actually pull some things on the fly and make my my container start up faster. That's something which does everybody need that? Yes or no? There are some trade-offs. The image has to support and be built with it in mind. However, we actually have these pluggable storage backends now that are much more trivial to swap in. And then the last one, from a big user-facing standpoint, is even better supporting things that are already integrating the engine, like BuildKit. Today, BuildKit can build multi-platform images. It can build a multi-platform image with a single platform, which is a little bit confusing. But this is actually how BuildKit does things, like bake SBOMs and provenance, software supply chain information into an image it builds. Today, we cannot store those in the engine. You actually, when you build, you have to push the result directly to a registry without stopping an intermediate engine, because we aren't able to store that kind of data. So it's trying to improve all these things. So that's more or less what we've been working on, but it's more than just like the source code and the engineering level. A significant part of things has been also working on the project health, improving processes. So that's been everything from trying to get more people participating in upstream. So like we mentioned, Microsoft and Mirantis, they're the easiest ones to pick on who are working with us upstream, because we have successfully, we're all trying to develop the same branches upstream now. So if we're maintaining a previous release branch, we're trying to pitch as big a tent as possible and get everybody under it to try to share that workload and further economize. I mean, despite the fact we say the project is moving much faster than ever, there's still limited resources. And this is a bit of a confusing process. Like, it's a work in progress. We need to document it better. There's lots of, it's a little bit part in our dust. There's lots of things that are confusing about it. The canonical one that happens most of the time is there used to be a Docker CE repository that was essentially a soft fork of the Moby project that defined what did Docker build and call Docker CE. We don't have that anymore. We only build upstream releases from unmodified upstream source code, but then it leads to fun situations like, okay, so there's the Docker CE repository, which is deprecated. Docker CE itself is not deprecated, but I mean, that identity question, even what is Docker Inc., what is Docker CE, what is Moby, becomes confusing and leads to just this README gets somebody asking about it, probably a couple times a month. I had a slide here to talk a little bit, if you had an abundance of time, about the whole Kubernetes removing Docker, but I think we very much want to skip that since we are a little bit on the shorter side for time. This has been hammered on so many times, but it's still one of those things. I have this here because not only does the whole Docker CE deprecation thing confuse people, this is the one that people get confused by and ask about the most. But I think we'll cut that for time. So then let's just talk a little bit about future work and ambitions. These are all very arbitrary things that people on the team have thought of. More or less, what would we like to do in the next 12 months once we finish this containerd thing, or what would be interesting to do in the long term? There's not really any level of commitment or serious evaluation of how realistic they are, but just some ideas, especially some of the problems we're solving, enable us to work on some more interesting tasks. Or the resourcing we have, again, enables us to work on things like, well, if anybody's used the Docker Go client, I think they probably would agree that it's not the easiest thing to use or the best. That's something that we're able to actually seriously look at again. Yeah, and then back to you, Sebastiaan.
So the question is, can you participate? For sure you can. And the question is always, people ask me as to, do I need to code? Do I need to understand the project? And I don't think it's always needed. I think the most valuable contributions are participating in the project. It's the way I got started. I didn't know Go, the language. I didn't know Docker. I didn't know about namespaces and what the hell it was. But I started to learn, and I started to participate. People reported tickets, and maybe I had the answer because I ran into the same issue. And in some cases, I saw the documentation, and it was like, I don't understand anything of this. Maybe I can rewrite it with the knowledge I gathered. So yes, if you want to participate, feel free to. Please do. If you have feature requests, post them. If you have, more importantly, if you have a use case as to, hey, I tried to do this with the Docker engine, and it didn't work. It didn't solve the thing I was trying to do. That's often more important than a full feature request. Always happy to learn. Always participate. And if you have any questions after our talk, I will be around, or otherwise you can find me on GitHub, probably. Did we have more slides? I don't know.
I mean, I think we'll skip through that one. So yeah, we've got a little bit of time for Q&A. If anybody has questions, I believe there are microphones on either side of the room. And then we should also, if there are any online questions, we should be able to read those off for you as well. But if not, especially we'll be around the whole event too. And there are plenty of other people who are quite knowledgeable on a lot of these things as well.
Nothing in the room, looks like. In that case, I would say thank you.
Well, thank you.
Yeah, thank you very much.
Sebastiaan, thank you very much.